carefully. Here we are given the position function. Position, yes, is a function in terms of t, where t is 0 and bigger. Now we need to find the velocity and acceleration function. So let me answer part A. So the velocity, let's denote by v, which will be a function of t. Velocity is just the rate of change of this position. That means derivative of this one. Okay, just the derivative. And let's find the derivative of this function. You can think like x. So 3 times 2, 6t squared minus 6t minus 12 plus 0, not needed. That's the velocity function. We also need acceleration. Let's denote by a. Acceleration is derivative of this velocity, so v prime. Find the derivative, so 12t minus 6. Okay, that's the acceleration. Let's do part B. At what times is the particle at rest? Rest means when the velocity is 0. Velocity 0 means the rate of change is 0. There is no rate of change. That means the particle is at rest. So for that one, we set the velocity 0 and find time t, solve for t. That means this function 6t squared minus 6t minus 12 equals 0. So this is a quadratic equation, degree 2. So we'll get 2 different times. Let's factor. To solve for t, let's factor. If it does not factor, then we need to use the quadratic formula. 6, 6, 12. So we can factor 6 out of 3. Then that equals 0. Let's try to factor this one, t squared. So trinomial means it might factor in this way, t squared, t times t, 2 times 1, 2. To get negative in the middle, here negative, positive. Okay, positive. So t plus 1, okay, this is positive sign. So that gives t equals negative 1. And then this gives t equals 2. And 6 is never 0, so no contribution. So there are 2 times when the particle is at rest. When time t equals 2 seconds and negative, okay. We are talking about positive time. So we need to disregard this. So the answer is then, at what time? Just only one time is the particle at rest. So particle is at rest at t equals 2 seconds. Okay. Now let's do part C. On what time interval is the particle moving to the right or left? So the convention is when the velocity is positive, we consider the particle moving to the right. Velocity negative means moving to the left. So we need to do the interval test here. So starting 0 inclusive, it's forever, because the thing is here, t bigger than equal to 0. Okay, so starting 0 forever. And we know that the particle comes to rest at 2 seconds. We found in part B. So 2 seconds, 1, 2, somewhere. So it will be moving to the right, then left, or moving to the left and right. So we'll determine. So we need to check the sign of velocity. If the velocity is positive here, moving to the right. So sign of velocity. So let me put vt. And the velocity function is where? This is the velocity function. Pick a representative, maybe just 1, 2 all the way, maybe 3. Plug this one here. If we plug this here, this is 6 times 1 is 6 minus 6. 0 minus 12. So it's going to be negative. So in 0, 2, the velocity is negative. That means the particle is moving to the left. Okay. And 2 all the way, do the same thing. Plug in 3. 6 times 3 squared minus 6 times 3 minus 12. It will be plus sign, moving to the right. So part C, moving to the left on 0 to 2, 0 inclusive, and at 2 it comes to the rest and then move to the left, moving to the right, moving to the right on interval after 2 seconds to 2 all the way to infinity in this case, but generally there will be a time, but we don't have that. Part D, determine the time intervals, okay, like this one, time intervals, when the particle is speeding up or slowing down. So speeding up and slowing down depends on the signs of velocity and acceleration. So we need to have two graphs for velocity and acceleration. So this is already the velocity thing here, so let me copy that here. Okay, so starting 0, okay, this is the velocity, so that's 0, not there, wrong place, so 0. So the velocity is negative and we got positive. Now we need to do the same thing for acceleration. So acceleration is the derivative of velocity. Look at here, this is acceleration function. So let's set this equals 0. Acceleration is 0 where? 12t minus 6 equals 0. Add 6 both sides, divide by 12. So t equals 6 over 12, 1/2. Okay, acceleration is 0 at 1/2. This is 2, maybe 1/2 here. It's the only one place. Okay, the acceleration is 0 at 1/2. So this is the sign for acceleration. Okay, now we need to test two intervals, 0 to 1/2 and 1/2 to all the way. So we can pick a number between 0 and 1/2, maybe 1/4, decimal to 5, and then we can pick 1. And this is the velocity, this is the acceleration function. We plug in here, 12t minus 6. If I plug in 1 there, 12 minus 6 positive, so it's positive. Let's put 1/4, 12 times 1/4 is 3, 12 times 1/4, 3 minus 6, negative, so it will be negative. Okay. Okay, now let me get rid of these. I mean, these are just the representatives, so let me get rid of those. Okay, this is 0, by the way. Now we're gonna combine these two graphs to determine if the particle is speeding up or slowing down. So combine both of them. So it will be 0, 0 is common for both, 1/2, so 1/2 will be there. So let me put in this way, and 2. So this negative throughout here, so these are all negatives here and here, positive. Negative here, positive, is also positive. Positive all the way, okay? I'm writing in two places because of this 2, but it's positive all the way. And here to here, negative. And the velocity at 2, left of 2 is negative, right of 2 is positive. Okay, this is 1/2, by the way, this is 1/2. So we need to consider 0 to 1/2, 1/2 to 2, because we need to merge these two graphs, 1/2 to 2 and 2 to infinity. If the signs of V and A are same, plus plus or minus minus, the particle is speeding up. If the signs are different, plus minus or minus plus, then the particle is slowing down. So 0 to 1/2 is a negative negative, so speeding up. The particle is speeding up on 0 to 1/2. Okay. And then this 0 right after 0. At 0, okay, at 0, we don't have to include, but we can include here 0 to 1/2. And what happens here to here? 1/2 to 2. So negative positive means slowing down. One half to 2. minus plus 1/2 to 2. Okay, this thing let me put in, okay, let me put in terms of bracket. Okay, unlike the first one, so this was 0, 1/2 to 2, and after 2 positive positive, so it's speeding up 2 to infinity. Okay, 2 to infinity. Okay, that's final.